Hi everyone, and welcome to Lesson 4.2, Complex Numbers. Complex numbers are made up of two parts. They are made up of a real part, which we're used to working with real numbers. In fact, a lot of times the domain of the functions that we look at is all real numbers. And if we're specifically saying that it's all real numbers, that implies that there must be some other type of number out there. And that's what we're going to learn about today. We're going to learn about complex numbers. Complex numbers are made up of two parts. One is the real part, and we will call that A. So this is the real part. And then we're going to have an imaginary part. And so the imaginary part is represented by b times I. So b is a coefficient and I is the imaginary unit. We're going to define the imaginary unit I as being equal to the square root of -1. We have never been able to take square roots of negative numbers before, but now that we are introducing the imaginary unit, we're going to be able to do just that. In fact, if you put any negative number into your calculator and try to take the square root of it, your calculator will give you an error. But we are going to learn a technique today where we can actually take the square root of a negative number. And so if we have two complex numbers and we set them equal to each other, that means that their real parts must be equal to each other and their imaginary parts must be equal to each other. So for example, if we have a complex number a plus bi and another complex number c plus di, the real parts have to be the same, the a and the c. How do I know that those are the real parts? They're the ones that don't have i's on them. So if a and c are equal, then that means that we can create a new equation that just says that a is equal to c. And if bi and di have to be equal, the imaginary parts have to be equal, then we can create a new equation that just says that b is equal to d. So basically what this allows us to do is take one equation that's made up of complex numbers and split it into two separate equations, one with the real part and one with the imaginary part. So let's take a look at what that's going to do for us. This first example, we're wanting to solve for x and for y. And normally we can't solve for two variables if we only have one equation. But when we're dealing with complex numbers, we can take this one equation and break it into two equations. So I'm going to identify this as my a value and this as my c value. Now remember that a and c are the real parts. They're the parts that don't have an I. So I can say that a is equal to c. So negative 10x is equal to 30, and I can solve this equation. I can divide by negative 10, and that leaves me with x is equal to negative 3. Now the second part of this says that our imaginary parts are equal to each other as well. So this is an imaginary part, and this is an imaginary part. So I'm going to identify those as b and d. So b has to equal d, and the b part of a positive I is just 1. The d part of negative yi is negative y. So I have 1 is equal to negative y. In order to solve for y, I need to get rid of the negative sign. So remember that this is like a -1, so I can divide both sides by -1, and that's going to leave me with this canceling with this, and y is equal to -1. Let's go ahead and look at another example. So in this example, number 2, I can identify real and imaginary parts again. So my real part, my a value is 44, and my real part on the other side is -1/4 x, so that will be c. So again, a is equal to c, And so I can say that 44 is equal to negative 1 over 4x. Now, I want to solve for x, which means that I need to get rid of a negative 1 over 4. In order to cancel a fraction and make it go to 1, I need to multiply by its reciprocal. So the reciprocal of negative 1 over 4 is a negative 4 over 1. And then I can multiply this other side by a negative 4, technically over 1, but we don't have to write over 1. All right, if I have a negative 1/4 and a negative 4 over 1, those cancel. I'm left with x on the right-hand side. And then over here on the left-hand side, negative 4 times 44 is negative 176. Writing this in the more traditional way of our variable x first, I can say that x is equal to negative 176. Now let's look at the imaginary parts. The imaginary part of this equation is negative 1/2 yi. So this will be my b value. And negative 7i, that will be my d value. So remember, b is equal to d. So I have negative 1/2 y is equal to negative 7. I need to employ the same trick of multiplying by the reciprocal in order to get rid of the fraction. So I'm going to multiply by a negative 2 over 1 and a negative 2 over 1, or just a negative 2 here. These will cancel, leaving me with y, and then negative 7 times negative 2 gives me a positive 14. So y is equal to 14.